This is Mr. Anderson for Kellogg Community College, and we'll be looking today at Section 2 of Chapter 8. We're going to do the quadratic formula. The quadratic formula is a way to take your trinomials with descending powers of x squared, x, and a constant term, and if it's set equal to 0, we can find where it will cross the x-axis, and we can find real and imaginary roots for problems that are not easily factorable. The quadratic formula proof is on page 511, and it shows how just by completing the square using the letters A, B, and C will create the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4 times ac divided by 2a. It is important to know that when I will be doing most of my work here, when I do my substitution, I'll be putting my b, my a, and my c underneath the square root in parentheses. That way, if I have negative values, they will be properly shielded there when I use my distribution. Also, notice that the first term is negative b. That means that whatever your b is will be the opposite when you plug it in there. A nice way to try to remember this is you can do so as there's many videos with songs and kind of little tunes to remember. But the way I like to think about the quadratic formula is like a truck. The truck portion of it, or the driving part, is negative b. The plus or minus is the hitch or the trailer of the truck, one to connect the truck to the trailer and the other to connect the brake cables. The square root is the actual trailer part, and the stuff on the inside in the parentheses is the cargo. It is important to know that this cargo is going to be called the discriminant in the next section. So anything inside of this trailer here is considered the discriminant, which again will tell us about our solution sets. And the wheels, which I will expand a little bit right here, of the truck, 2 times a, so you can kind of see that the driver is negative b, plus or minus the cargo, or the discriminant, b squared minus 4ac, all packaged up in their boxes there with the parentheses, and the wheels are 2a. Now, if you're looking at the quadratic formula, the first thing you need to do is figure out what your a, b, and c is. And your a is the coefficient of x squared, b is your coefficient of x, and c is the constant term, or the y-intercept of your problem. So what we're going to do is we're going to take a look at this whole thing where we're going to label our a, b, and c and then plug it into the quadratic formula above. My a is 1, my b is negative 2, and my c is going to be negative 2 as well. So we're going to have negative b. So since my b is negative and this is negative 2, negative 2 is positive 2 plus or minus the square root, and this is where I use my parentheses here, negative 2 squared minus 4 times 1 times negative 2. All divided by 2a, which is 2 times 1. Now, I would suggest that you compute this discriminant first, or the work underneath the radical. Using technology, you get 2 plus or minus the square root of 12 divided by 2. Now, if you didn't get 12 under the radical there, a common mistake is that you're typing in negative 2 squared and not using parentheses, because the graphing calculator needs to have parentheses if you want the negative 2 to be properly multiplied. Another common mistake is that this, instead of you putting a subtraction sign on your calculator, you would put a negative sign. Make sure it looks like a subtraction sign when you do it. So that will there give you the answer of the square root of 12. Now, using our rules from the last chapter, we have to take any kind of radical and break this into evenly or more simplifiable radicals. So the square root of 4 times the square root of 3 is a way to break this down into 2 plus or minus 2 square roots of 3. Now everything here is divided by 2. I'm going to stress that you split this up into fractions because it'll be easier to do simplification this way. because you can now see, since the denominator is a monomial, you can break this into 2 divided by 2 plus or minus 2 square root of 3 divided by 2. This gives you 1 plus or minus the square root of 3, because you're going to have 2 divided by 2, which is 1, 2 divided by 2, which is 1. This gives you two answers, of course. One answer is going to be 1 plus square root of 3, and the other answer is going to be 1 minus the square root of 3. If you turn these into decimals and take a look on your calculator, you will see that this graph crosses the x-axis at these 2 points, be it they are decimals. You also might have realized from the start of the problem that this was impossible to factor using whole numbers, because two numbers that multiply to make -2 are not easy to find for making -2 as well. Same thing here. Two numbers that multiply to make 3 and add to make 5, not using whole numbers, so we're left using the quadratic formula. The quadratic formula is also very useful for problems that can be factored. It's just that factoring is faster, and also more useful for your later courses. So we're going to do -b. In this case, the b was positive, so it turns negative, plus or minus the square root, b squared, so this is in parentheses, 5 squared. Not as important when the b is positive, but I still want to get into that good habit. Minus 4 times a times c. Alright, we're going to then divide by 2a, which is 2 times 1. So I have -5, and using technology, if you compute this correctly, you get the square root of 13. Again, look to see that this was a subtraction sign and not typed in as a negative. Divided by 2. There's really not much to simplify in this, so I'm going to go to the format of the problem that I enjoy, which is splitting these into two fractions, separated by the plus or minus, and with the denominators. So obviously this gives you two answers. The first answer is -5/2 plus square root of 13 over 2. And if you computed that and got a decimal, you would have seen that that's one place where this crosses the x-axis, and -5/2 minus square root of 13 over 2, which is another place where it crosses the x-axis. I will show you that demonstration now, because I can use my emulator software here. Unfortunately, as you see, the problem went away, but I can go to my first calculator here and go and type in this equation. I'm going to go x squared plus 5x plus 3. Now you can see that this does cross the x-axis in two different places. So what I'm going to do is go to my final answer here and check this out. It looks like I'm estimating between -1 and 0 and between -5 and 4 here, since this is -1, 2, 3, 4. So between -4 and -5, and between -1 and 0, those are my two answers. So if I go to a clear screen here and type in my -5/2, -5/2 plus square root of 13, close that off, divided by 2, this is going to give me one of my two answers, and this was, as I assumed, it was going to be between -1 and 0. By recalling the last answer by hitting second enter, I can change this to minus and verify that the other answer is going to be between -4 and -5. As you see, this is between -4 and -5. What's nice to see is that you have the pictorial representation of the quadratic formula. You also have the actual answers here if you converted those into decimals. This is the reason why you also couldn't factor this out in your head, because these were definitely not whole number answers. Alright, well, let's scroll down and do the rest of the page here for to end the first video. And then the second video we'll do the second page. Now, in problem number 3 here, you're going to have to clear the denominator. So as we learned in the previous chapter here, clearing the denominator is when you multiply every single fraction by the lowest common denominator. So what does x, 1, and x squared all have in common? That's right, x squared. Therefore, I can multiply x squared by x squared by 1, and x squared by x squared. And that's going to simplify things. X squared divided by x is going to be just x. So this becomes 9x. Well, x squared divided by 1 is x squared, so this is just minus 2x squared. And x squared divided by x squared is just 5. It is important to note that I have to take this problem and change it so that it's usable with the quadratic formula. I'm going to use my commutative property to switch the 2x squared to the front with my 9x. And I'm going to use the inverse operation to subtract the 5 from there to there to give me my quadratic formula in A, B, C format. It's easier to see it this way, even though you maybe could have seen the ABC without doing the manipulation. My A is negative 2, my B is 9, my C is negative 5. So now we need to put this into our quadratic formula. Negative b, since my 9 was positive, it turns negative, plus or minus the square root, and I'm going to take my 9, square it, minus 4 times a, noticing I'm putting that in parentheses, and c, and I'm putting that into parentheses as well. Now, when you type this into your calculator, be very careful with all the subtractions and negatives. So do your discriminant first. Type in parenthesis 9, parenthesis square, minus 4, parenthesis negative 2, parenthesis negative 5, parenthesis, and then hit enter. Try not to do the square root at the same time. It's easier to get your square root, and if it's not, like in this case, easily rootable, you're just going to keep it as the square root of 41. The square root of 41 is then going to be divided, whoops, I forgot my 2a up here. So this is 2 times negative 2. So this makes negative 4 as my denominator for my quadratic formula. I am going to split this up into negative 9 over negative 4 plus or minus the square root of 41 divided by negative 4. Now there's some simplification we have to do here. First of all, do not leave negative 9 negative fourths. Make sure that is a positive 9/4 because double negative errors are going to occur. Also, you'll notice that this is added and subtracted. Now, it is common to just drop one of the negatives from the problem because adding a negative and then subtracting the negative is going to give us the two same answers. So it's common that if we have a negative in our denominator or a single negative in this problem after the plus minus, we simply drop it for simplicity's sake. It is technically not inaccurate to leave the negative under the problem with the 4, but it's just unnecessary since we're going to be adding and subtracting anyway. Problem number 4 is given to us straight up without any kind of manipulation necessary. So you might be wondering, well, what's the catch? And there is a catch in this problem. Now, if you tried factoring this, there aren't two numbers to multiply to make 4 and add to make 1. 4 only has 2 and 2 and 1 and 4, and those don't make 1. But the catch comes in when we do our quadratic formula. Negative b plus or minus the square root of b squared, in this case 1 squared, minus 4 times a times c. Now what's going to happen in this problem after we compute the 2a, which is the 2 times 1, sorry I wrote that there, when we compute the discriminant or the square root, you're going to notice that the answer is going to be, for the first time this worksheet, is going to be a negative number. In this case, it's negative 15, because you have technically 1 minus 16, which is negative 15. Now, from the previous chapter in section 8, we dealt with the square root of negative numbers. This is a situation where you have an imaginary number. So we're going to split this into the square root of 15 times the square root of negative 1. That way we have negative 1 plus or minus the square root of 15i. Now, some of you may work a little faster and just say, well, if I see a negative under the square root, can I just bring it out into I? Well, sure, but that's the actual step of why we can do that using our product rule from the last section. So now we're going to split this up. Negative 1 half plus or minus the square root of 15i divided by 2. And there's our answer. Now, unlike the previous problem, which we could type into the calculator, this is a problem that has imaginary answers for where it crosses. So it won't actually cross the x-axis in these locations. But it is important to know that this does have imaginary solutions for the problem. So when you have a square, the fundamental rule of algebra is you'll have up to 2 real answers. In this case, this problem has 2 imaginary answers. To finish up the worksheet, we're going to be doing 2 more problems here, problems 5 and 6, and they'll take a little bit of manipulation before we get to the quadratic formula part. Number 5 doesn't need a lot of manipulation because all we need to do is move the 2 to the left-hand side. So this is going to be 15x squared plus 7x minus 2 equals 0. So my a is equal to 15. This is a situation where a is a pretty large number here. B is 7 and c is equal to negative 2. Negative b plus or minus the square root of b squared, in this case parentheses 7 squared, minus 4 times a, which is 15, times c, which is going to be my negative 2. All divided by 2a, which is 2 times 15. So negative 7 plus or minus, and here we have, if you do all of this correctly, you get 169. Now what's different about this problem than the other 4 that we've had before it is the square root of 69 is a perfectly rootable number. So let's keep going and have our 2 times 15, which is 30. So this is negative 7 plus or minus 13. And if you're unsure if something's rootable or not with your calculator, just go ahead and check. Now, you'll see that I have no square roots. That means no irrational numbers left in my problem. So we are really required to split this up and actually simplify it as much as possible. So we have negative 17 plus 13 divided by 30. And we have negative 7 minus 13 divided by 30. Now I'm not splitting this into 2 fractions yet because I can still do some simplification. Negative 17 plus 13 gives me an answer of 6 over 30. And 6/30 is 1/5. And that's where it's going to intersect the x-axis at about 1/5 or 0.2. Now negative 17 minus 30th is negative 20 over 30, which simplifies to negative 2/3. So this graph will cross the x-axis at 0.2 and it will cross at negative 0.6 repeating. Alright, our final problem today is going to deal with this problem that has, well, it looks like it still has its little tag here from Microsoft. We're going to do some simplification to get this into the quadratic formula moment. We're going to distribute, so this is 5x squared minus 5x minus 7. And on the right hand side we're going to distribute here, and this is going to be 4x squared minus 8x. Alright, so let's move some things around here so we can get the problem started. Let's move the 4x squared to the left side and move the 8x to the left side and get this equal to 0. So this is going to be x squared because 5 minus 4 is 1. And this I'm going to add over here, so this is plus 3x. And then this is going to be our minus 7. My a is going to be 1, my b is going to be 3, and my c is going to be negative 7. Negative b plus or minus the square root of b squared. In this case it's going to be parentheses 3 squared minus 4 times a times c all over 2a, which is just 2 times 1. Using our calculator we're going to compute the discriminant plus or minus. This is going to be the square root of 37, and 37 isn't rootable using any numbers in our root chart, divided by 2. So we're just going to move on to our pieces here where I split them off into 2 fractions and get our answer there. Alright, thank you very much. And we'll do the next part, we'll do the next 4 problems in the next video.